On the last time we met, we talked about amplitude and how that affected and we talked about the original sine function, the original cosine function. Now we talked about amplitude. Now we will talk about the period lengths and how they can change. Normally, a period length is going to be just like one full revolution around a circle is going to be the length of 2 pi. Whereas here, whenever we talked about the last time, we talked about the amplitude as far as basically making the sine or cosine function and the graph kind of spike or have a vertical shift or shrink. Whereas today we're going to talk about either shortening or lengthening the period lengths. So instead of it being 2 pi to take before things repeat, it may be quicker or it may take a little bit longer. So before it was like whenever we dealt with quadratics and cubes and absolute value and how we adjusted any sort of function that we had. You know, remember we had A where it was the vertical shift or the shrink, and then we had the H where it moved it left or right, and then K moved it up or down. Okay, we'll talk about the phase shifts tomorrow, but for right now, basically now instead of having it be a vertical shrink or stretch, now it's going to be like a horizontal shrink or stretch. Okay, we're either going to elongate the graph and pull it out to where it's going to take it longer to complete a full rotation or before it starts to repeat our values, or we're going to shorten it and we're going to kind of push everything closer together. So the big thing happens here is if there is a value, so A was whenever there was a value in front of the cosine or sine function, depending on which one it was. Okay, that's still your amplitude. That's not going to change. So if it's negative, obviously it flips, but your amplitude is always going to be a positive value. Whereas now, whenever we talk about the period length and how that changes, it is if there is a number in front of your x value. So after sine or cosine and you're multiplying something by x. Okay, it can be something that can be smaller than x, it can be bigger than 2 pi, it can be less than 2 pi. The biggest thing is that it has to be positive, okay, with any of these. The one thing that it won't be for right now is it will not be negative. Okay, it will be bigger than 0. So all it's going to do, or the only way that it's going to change, is it's going to take 2 pi and we're just going to divide it by whatever our b value is. It doesn't change from cosine to sine. We do the same things. Obviously, the only thing that's different is that whenever we deal with sine, it's going to always start at 0, and cosine is always going to start normally at 1. So it says determine the amplitude and the period length and how that's going to change, and then we will graph our function. So first thing is we've got to look at what our a value is. So whenever we do is, if A is 3, so our amplitude is going to be at 3. So if A is 3, then that means our amplitude is still at positive 3. How long, if our normal period is at 2 pi, our B value is at 2, from here. So how long is our actual period length going to be? What do we need to do with the 2 and a 2 pi? Exactly. Take 2 pi and divide it by 2. So instead of our period length being 2 pi, 2's cancel, and our period length is just going to be pi. So instead of, whenever it was 2 pi, normally we counted by pi over 2, right? So normally whenever, if we have our original, so if I just draw our original and I'm just going to put it in red, normally we would put our values, we'd put our zeros at pi, we'd put our zeros at 2 pi, and then we would go with 1 and 3 pi over 2. So if the red one was the original, if the only thing we did was change the amplitude like we did the last time we talked about this. So if our amplitude was just the 3, if this was the only thing that we focused on, our value at 0 didn't change, our height changed, it's still at 0 here, and then it's still going to be at -3, and then it's still going to be at 0. So the red one is just if it is sine of x. The blue one would be if it was, looks something like that. This would be if it was 3 sine of x. Whereas here, whenever we actually take the the period and we shorten everything. So normally if we would go at 0, we would go at pi, and we would go at 2 pi as far as my zeros are concerned. So normally we cross the zeros here and here. We cut down, or we divided our original graph, or we shoved it into a window that's now half the length. So where are my zeros going to be at in terms of where they were originally at?
They're going to be half the value.
Yeah, half the value. So if it's normally at pi, where's my next 0? The 0 is not going to change here at 0, 0. Okay, because we're not shifting it left or right. It's still going to start at 0, 0 every single time. But now, instead of having a spot at 2 pi, where is it actually going to end at before it starts to repeat? What's half of 2 pi? Pi. So if it's going to end at pi, where's the other place that it's going to cross at 0? Where? Half pi or pi over 2. So then so it's at 0 where it's green. They're at 0, pi over 2, and pi. Okay, I could continue to draw it and go at 3 pi over 2 and have a 0 just as well. Okay, that's okay. I could do that again and draw basically what that means is I can have this thing go 2 times before it's going to go for your normal period length. So then where's it going to spike? Where's the amplitude of 3 going to take over? Normally it was at pi over 2. Okay? Originally it was right here. Now where's it going to be at? Pi over 4. Okay, so basically halfway, pi over 4, and then do the same thing at 3 pi over 4. So it's going to look something like this here. Okay, and again, I could draw this twice. What that 2 basically tells me is that I can draw this thing twice in the same original window that I had. So then in green, it is 3 sine of 2x. So then on 6, same thing. Determine the amplitude and the period if we have y equals -3 times cosine of pi over 2x. Graph the function for, which basically between -4 and +4. Okay, so our window changed. What we will worry about first off, what's the, if my a value is -3, then my amplitude is just a +3. My b value is pi over 2. So if b is equal to pi over 2, for my period length, I'm going to take 2 pi over 1, and I'm going to divide it by pi over 2. So I can either go, I'm just going to go outside, inside, so I have 4 pi over pi. So my period is a length of 4. Okay. Surprisingly enough, y it is here. Okay. They're going to give us, the reason why they give us the values that they do, or basically because they're useful. They're not going to give us, 2 pi whenever that may or may not fit. So then whenever we graph this, every time that this thing is going to cross, so instead of crossing at pi over 2, 0, everything's going to work out to be nice and neat as far as where my graph's going to lie. Normally, okay, so normally where do I start at with a cosine function? Normally I start at 1. So if we would do this normally, I would go to 1. It would bottom out, okay, and then it would end at 1. Now, the problem is, basically, I want to shorten this, or every reference point, okay, I'm going to take that 4, okay, every reference point is going to be at a certain value. So, in this case, it's a -3, so if it's normally at negative or +1, where's my new starting spot going to be on my y-axis? If it's at a -3. Normally it starts at 1, right? So what's at -3? Where's it going to start it at? What's 1 times -3? -3. Now, it's also going to end at -3, okay, and it's going to have a high point of +3. Now, normally whenever we go a length of 2 pi, we do the same thing, we shorten everything up. But now every reference point is, if I would quarter this thing, right, I have 5 points normally, okay, and I quarter it. Each quarter would be pi over 2. If I quarter 4, where's every section going to hit? Or how long is it going to be? 1. Okay? The reason why we use -4 to 4 is because at -4, or excuse me, at +4, it's going to end here at -3. What's halfway? Halfway is where normally it either peaks or valleys, right? On a normal one, it would look something... On a normal one, it would go like this, right? Kind of up there. But in this case, it's going to peak at 2. It's going to cross here at 0. And it's going to look something like this. Everything's still going to fit. 0, boom. We still have the same type of reference points, but instead of it doing it at pi over 2, at pi, at 3 pi over 2, okay, we can figure out, because we're just, every time we do this, we always quarter it. Okay, we look at each section. We have 5 points, or we've always used 5 points because we always start with the beginning and have the end. Whenever we have those 5 points, it just sections everything off into quarters, just like it did before. Okay, the last one it quartered everything off, or we took everything down by half. Whereas here, we're just quartering everything off, and since the full period length was at 4, well, that means that each quarter of a length, or of a period, is going to be 1 in length. So those values are going to change. Okay. What happens for right now to your graph? It doesn't change. The only thing that's going to change is if it becomes negative or positive. Okay, if my amplitude changes. As far as how I go off of my reference points, it's just depending on how that period changes. Okay, it may be a normal length. It may be in terms of pi. It may be in terms of pi over 2, pi over 4, whatever. Okay, but for right now, realistically, the overall change of the graph isn't really any different because we're not shifting it left, we're not shifting it right, okay, we're not shifting it up or down. Okay, all we're doing is just basically either pulling from the ends or pushing from the sides. Okay, it's just a matter of how hard we push in and how hard we squeeze it together, or how hard we pull it apart or push it down together and kind of try to flatten everything out. Alright, last one. So you have, it says determine the amplitude, the period, you have y equals 2 times sine of 1/2 x. So you want to graph the function basically between 0 and 8 pi. Again, they are going to, or we or they, whoever, okay, we're going to give you a window as far as whenever you graph the function that will at least have one value in it, or have one full period in it. Okay, so the easy part hopefully should be to find the amplitude. So my amplitude, if it is at 2, okay, it's positive, so my amplitude is going to be at 2. So that means the height is only going to get up to 2 or -2, and it's going to be everything in between. Okay, it's a sine function, so that means it's going to start at 0. So it's going to look something like this here. I'm going to have 1 and 2. So it's a sine function, so it's going to automatically start at 0. It's just a matter of where's everything else whenever I graph this. So if b is equal to 1/2, what do I need to do with my period length? What am I going to divide 1/2 by? 2 pi. So I'm going to have 2 pi divided by 1/2. So it's really similar to what it was before, but at the same time, it's going to be, a period length is going to be 4 pi. So I want it to go from 0 to 8 pi, so I'm just going to basically have everything marked off, and there's 1, 2, 3, 5, 6, 7, 8. I'm going to make this 8 pi, 6, 5. Here's 4 pi. So if a full period is at 4 pi, where are my reference points going to be at? Where's this thing? It starts at 0, 0. Where's it going to end at? Where's one full period going to end at? 4 pi. Okay? This is going to be your number. Whatever number this is right here, that's where your period's going to end. Does that make sense? Okay? So if that's where your period's going to end, it's going to end at 4 pi. It's also going to end at 8 pi. So then what I want to do, I want to section this off, right? How many sections does each sine or cosine function have?
4.
4, right?
Yeah.
Because, so halfway, what happens between wherever it starts and wherever it ends? What happens right in the middle? Crosses at 0 again, right? So it crosses at 0 right here at 2 pi. What's it going to do? So basically halfway here, it crosses at 0 again. What's it going to do here and here? It's either going to do what? It's going to peak or valley, right? So it's not negative, so what's it going to do at the first one? Is it going to peak or is it going to valley? It's going to peak. Where's it going to peak at? 2. What's it going to do at the other blue line? It's going to valley, right? Go up, down, up, boom. Now, I need to continue to graph it, so same thing. What's it going to do basically halfway between 4 pi and 8 pi? What's it going to do right in the middle? 0 out. What's it going to do? It's going to peak again, and then it's going to valley. It's going to peak up here at 2. It's going to valley down here at -2. Here's one period. There's the second period. Okay. This number, that 4 pi, is basically going to tell you where it's going to end at. Okay? And then you just have to quarter it from there. You just have to know what the sine function looks like versus what the cosine function looks like. Sine's always going to start and end on 0. Okay? It's going to halfway, it's going to be at 0. Right? Okay? But that number, so you always, if you can find your bookends, if you can find where it starts and ends a period, okay, everything else, okay, in high school terms should be cheese, okay, because you're just going to go halfway. Now, what's a cosine going to do? It's going to either be up top, okay, or it's going to be down below. It's either going to make a bell or it's going to make just one big valley, okay. But you know that either on either end of cosine, it's either going to start at basically 1 or normally 1. So where's the middle? It's going to be that bottom part of that valley. Okay. Where's it going to cross? Well, it's going to cross at the next step out. Okay, or those halfway points, the half of the half. or that quarter, if you want to look at it that way.